Hello everyone and welcome to another episode of Link Digital Online Series. Today we'll be looking at another aspect of computer vision, which is object recognition. So for today, we'll be looking at how we can identify a face as well as the eyes, the features on the face, using some of the already available libraries or XML files that we'll call, where there are cascades that are built for easy recognition. So it's built on thousands and many thousands or even more data sets, and is trained to recognize certain objects. So later on we will start to try building our own, but for today let's just use one that is already readily available. So the initial parts are the same, but for this we will be removing most of it. But let's just remove this first. Right, so first we have to import the so-called Cascade files. So these Cascade files are external files that we'll put in the same directory as this file, which is called linkdigital.py. So we'll import them. So we'll use CV. We'll import a face classifier. So we'll do face Cascade face recognition. So we just call it face rec, and then we'll use the method in CV2 called Cascade classifier. Okay, and the first argument it takes is actually the only argument that this method takes is the Cascade file itself. So we will call it we'll call the file later, but let's look at that, and we'll have the normal while true. And so in each frame, if we detect a face, we'll want something to be drawn. So it's back to what we did previously on bounding boxes. Okay, so we're looking at the frontal face default file, and we will click on it, and we'll click raw. So raw will just open up on like this. So all the details are here. So what we do is we'll right click or control click on MacBook, and then we'll click save as. We'll just leave the file name as it is. Over here we'll just copy it also. So just copy and make sure that the file format is in XML text. And we just press save. And yep, you can close this window for now. Right, so let's go back to where the file is. So it is on the desktop. Right, so on the desktop over here, we have the Cascade file, and we have our Python script. So just make sure that they're on the same directory. So if both are on desktop, it's fine. If not, we can put both of them into a folder and just work from there. So as what we have over here, what we need to do is we'll copy the name of the XML file and we'll paste it inside the classifier. And remember to add .xml behind. Yeah. So that's it, and we just save it as a string. So just remember to have the inverted commas on both sides. And so now let's go into the loop. So if it's successful, we want to capture the faces. So first we have to do image. So right, so from frame, now we have to do some processing. So let's just change it to gray first, because cascades are usually done in gray. So it gives a better result when it's in gray, because you're looking at values in terms of technically from 1 to 0 scale, where 1 is probably black and 0 is white. So everything's on the scale of 1 to 0 in the grayscale domain. So we'll do gray frame equals to cv2.convert color. Then we pass in frame, the cv2.color underscore BGR to gray, like this. And now let's look at our classifier itself. So we'll call them, we want to identify faces, so we just call them faces. And we'll do the cascade, so we'll call this back again over here, face rec. So then we'll use the method called detect. multi scale. Right, so we'll pass in this. Next, we'll go on to do a for loop. So if one frame has maybe like 5 faces, then we need a for loop to iterate through all 5 and draw bounding boxes around all of them. So we'll just do a for loop, but in this case, I mean, I'm the only one in the room, so it'll just be one face. So this is just for practical sake. So x, y will be the starting coordinates on the top left of the frame, and then we'll have the width and the height. So that's what you find in phases. So phases is actually an array of this 4 values, so all are integers. And then in phases over here, so we iterate through them, and we have the image. So we have grayscale, like we can just pass this output frame. So we'll draw this the rectangle, frame, and then we'll pass in the starting coordinates x, y, and we want to draw a rectangle. So the second argument is the top left corner, or coordinates of the top left hand corner, and the next argument will be the coordinates of the bottom right corner. So intuitively, the x coordinate will be summed up with the width, and the y coordinate will be summed with the height. So that will give you the bottom right corner of the frame. And then we'll pass in the color of the line that we want. So we'll just throw in the value. And then the last one is the thickness of the line, so 2. And what else do we want to have? We can have a cv2.text also. And now let's just like B, and we want to do our, which is right. So now we are ready to print the frame. So let's just take a look. So this is called the output frame actually. So why it was just frame initially, like frame here and frame, it's just that it will override the original frame and put the faces on it. So we can just call it anything we want, but this will just be the output frame. So we can make sure that we call it right, and if not, we can start running the script and see whether all's good. Right, so you can see that it identifies a face pretty well. So if you cover half a face, it kind of doesn't catch the face anymore. So that's the beauty or the trouble about this kind of program. So I think it does a pretty decent job in identifying faces. So yeah, I think it's really decent. Right, so just now there was an error here. For multi-scale, for the method to detect multi-scale, we only pass in the grayscale frame. So we only have passed in one argument. Yeah. So just now I was saying that like this, just you can also do it this way. It's more comfortable, so you don't have to create too many frame variables. So if you run the script, it will still work the same way, where it passes back into the frame. So, yeah, you get this. So yeah, I think it's a bit slow on that side, but definitely we can use our scale tracker and all to kind of like shrink down the frame. Right, so that's how we're going to start with doing image detection. And this will be useful because later on we'll be using it to detect certain cars or maybe a pedestrian crossing and all. And then we'll be seeing how we can pass a message or packet of information using certain communication methods, protocols. So we'll see that later on. But for now, that's about it. We'll be looking at the roads and all later on. So catch you later. And if you want to use the code for this tutorial, you can find it in the description below. So yes, thank you, have fun, and see you next time.